So to be able to resolve this name, I just simply included IOStream. But now that I'm passing my date as a constant reference, compiler says that if I try building it, I will show you, I attempt to build it. It says that right here, when you use your operator and you're trying to say get month, it is not guaranteed that get month will modify this date object, because you said that you want to be able to use it as a constant function. So here's the adjustment that I will make. I will simply go back to my declaration of class date and tell compiler that these functions are constant functions, which means that they do not modify anything inside this object. And I need to do this in two places: in the declaration of the date class, and then also switching to the implementation file. And here is my get month, get day, and get year. I have to tell here also that this is a constant function. This way, we declaring that it's safe to call these functions in context of a constant object. Because the idea here is that when we use cout combined with date, we want to formally make sure that the date is not modified by this operation. And to be able to provide that kind of guarantee, we declare get month, get day, and get year constant functions. And we write when we write implementation for our operator, we also declare date reference constant, which says this DT thing is a reference to a constant date. Therefore, you can call only constant member functions, which I just made them constant. So let's see if I can build it now. Yes, everything builds fine. I will run it, and you see that it still works and prints the same thing. But clearly this time, what happens is that I just use the single statement. Like I create the date object, and I use the single statement to send the date out to the output. So you can see that most of what we do defining our own user data types is relatively hard work, because we have to think about what member functions to create, what data the object should have, what kind of constructors we should be supporting. But the true benefit comes when we start using this concept. Look, the usage of it is just 2 lines: create object and then use it with cout. And it's really quite beautiful, right? It's just very functional and very brief. And if everything is done correctly, it's also very reliable, bug-free, and reduces the amount of code that we have to write. So that's what we have so far, what we have seen in this presentation so far. And I gave you examples of the live code of this. And in conclusion of this specific presentation, right, what we can say here in conclusion is that once again, C++ program is just a set of variable definitions and function definitions or functions. And when we take a look back to our Hello World example, which was happening a while ago during our first week, well, guess what? When we set cout hello world, of course cout is an object, but it provides an operator, okay, which basically takes this object and hello world as a function with 2 parameters. And so basically these 2 statements are equivalent, right? So to demonstrate, let's just make sure that we can do something like this. We can say right here std cout hello, right? But instead of, and I'll add new line over here. But instead of doing this, which is what we normally do, I will try replacing this by saying operator, and operator uh, left bitwise shift. And on one side of this operator, we use cout as a parameter, and then hello as another parameter, and use it as a function call instead. Let's see if I can build this. Yes, I can. And so if I run this, Control F5, you see that it says hello just fine, using this strange way of displaying hello with cout. So you should know that when we use objects and we use these objects with operators, what happens is that compiler is simply finding a matching function like this one operator for this type of object and this type of data, and makes a call into this function. So that's how we can today say that this is how internally this works. We still deal only with functions and with objects and variables. That's pretty much all the building blocks that we have in C++. Everything else is just organizational features. Example of organizational features are functions themselves, right? We can define functions the way we like them, give them proper names, provide good documentation for them, think what are purposeful parameters and everything else related to them. And likewise, we can also come up with brand new concepts like date and organize it properly, provide a set of member functions, constructors, and even overloaded operators to make everything work properly the way everything should be done. And you can see that, of course, it's really the convenience that matters, and this is the real benefit. Just create an object and send it to cout. But in reality, by the way, if you look at the implementation of date from top to bottom, every single function is used, right? Set date is used by the constructor, and month, day, and year are used by the output operator. And of course, themselves get month, get day, and get year, delegate all the work to already pre-existing library of general purpose functions, which we introduced part of our homework, right? So this is again very quick quick introduction to classes and the look and feel of the implementation. And you can see that in themselves, the concepts of classes is very simple. Just basically taking a bunch of functions and make them work with specific data, right? So you place some member variables and some functions inside the class, and using them together. So it's a very simple idea, but internally, organization all of this very likely requires us to create a project. And I'm switching to my Solution Explorer view and see now I know that my main CPP is responsible for entry point into my application and doing the high level work. And of course, serial date is a library. This is implementation of the library of useful functions. And finally, class implementation file, a separate implementation file, provides implementation of data members of the functions that I decided to place inside class date. Right? So these are all the organizational parts. And notice that it was also my decision to add these three files. Sometimes when I realize that my implementation files are too long, sometimes I can take this implementation file and split it into more multiple files, right? So for instance, this function gets very long, like maybe like 500 lines of code, something like that. It would make a sense to actually move it into a separate CPP file. Simply add it to the list of source files and cut and paste and move it to a different file, right? So decision about keeping and adding new files to our project is entirely our own decision. The only restrictive thing is that the declaration of a class has to happen within a single file. This thing cannot split between multiple files. This has to appear in a single file. And so you see that even those relatively simple manipulations that we did today require some effort and some careful organization. Once again, perhaps I spend more time, adding my header guards to the files where appropriate, as opposed to actually doing some sort of coding that does some computation. In fact, on my part, again, the whole computation was hard coded to hardly return values like 0, 12, 31, and 2019.